Today I want to tell you about a C library I've written. It's an alternative to existing libraries that I think is dramatically easier to use. I want to walk you through the problem that this library solves, how I came to my implementation, and we'll learn some pretty neat tricks with the C preprocessor along the way. Then, we'll get a look at the final library and how you can use it in your own projects. You probably already know this, but the command line is a ridiculously powerful interface for your computer. There are basic utilities like ls, which list all the files in the current folder, and cd, which changes what folder you're looking at, but there are also other tools like grep, which let you search for patterns across your files. A rule of thumb for designing these programs is to minimize interactivity. The program should take all the information it needs right away when you run it, rather than asking for the user's input while it's running. Can you imagine if grep worked like this? This is especially nice for optional arguments. See, grep has two required arguments, the pattern and the file name, but also has a number of other optional arguments. It's conventional to specify these with flags. For example, you can optionally specify the number of lines of context before and after each match, or you can pass a Boolean flag to prefix each line with its line number. Oh, and also, if you run a program without all the required arguments, or with the TAC-H flag, it will usually print out a help string, which tells you more about the options you have when running the program. I would venture to say that the majority of the programs we write are single-purpose and should be designed for the command line. So how do we do that? In C, your program begins in your main function, which can optionally take the arguments argc and argv. Argc stands for argument count and gives you the number of arguments the program took in, and argv stands for argument values and is an array with the value of each given argument. Notice that the 0th argument is pretty much always the name of the program. Using these, let's write a simple argument parser in C. Our program will take in two required arguments, which should always be at the front, one optional integer argument, and one optional Boolean flag. Let's write a function to parse the arguments. We need to have some way to return the parsed arguments, so let's create a struct type to store them in. Now we need a function to parse the arguments given in the command line. Our parsing could fail, so let's have parseArgs return an integer, 0 if it fails and 1 if it succeeds. And we're passing in a pointer to the arguments so that we can write to them as we're parsing. Hopefully you can see how we're structuring our code. We have a struct to store the values of our arguments, and a function to parse those arguments, and then our main function is putting it all together. Oh, and let's not forget that our optional arguments have default values. And we also want to make sure that if the user doesn't pass the required arguments, we should print out a help statement and exit our program. Note something cool we're doing here. We give the help function the 0th argument value, which is the name of the program, as part of the usage string. Now that we've gotten all of that out of the way, let's actually write our argument parsing function. First things first, we need to check if the user has included the required arguments. We do this by looking at argc. If the argument count is less than the number of required arguments plus 1 for that 0th argument, then there's no way we have enough arguments. If there are enough arguments, the best we can do is to assume that they've got the required arguments in the right places. Now we loop through the remaining arguments and check if they match either of the optional flags, and if they do, we can assign them as needed. Now this code isn't terribly complicated, but there's a much more sinister issue hiding here. What happens if we decide to add an extra required argument to our script? Are we going to remember to increase both of these magic numbers? Are we going to remember to add it to the help function? You can imagine that this becomes a bit of a nightmare to maintain. It's also worth mentioning that this is very common functionality, so it's a little bit silly to have to implement it from scratch every time you write a program. A much better solution is to write a little library for this. Sure, it'll be a little more work up front, but we'll also be able to share the code between projects, saving time in the long run. There are, of course, some libraries out there that make argument parsing easier, but from what I've seen, they don't really solve my issue with maintainability, nor do they do much to improve the verbosity of our code. So with this, and the general can-do wheel reinventing attitude of your average C programmer, I decided to make my own arg parsing library. I find that whenever I'm working on tools for developers, a good place to start is thinking about what I want the code to look like when someone uses my package. First, we'll need the developer to specify a list of arguments somehow, and maybe these will need to be separated by the type of argument they are, just for convenience. Then, we would need to somehow create those structs and functions we had before, like the args type and the parseArgs function, but this time using the lists of arguments specified in the arrays. Herein lies the first clue. See, when you're defining a struct in C, you have to give it all of the arguments right then and there, or at least it needs to know all of the arguments at compile time. So if we want to change the text inside this struct, we're going to need to use C's preprocessor. We don't have time to cover every detail of the C build process, but one part that's important to know is the preprocessor, which is what your code goes through before it gets given to the compiler. We actually saw the preprocessor in action earlier when we wrote the include statement for all of those libraries. What you need to understand is that the preprocessor literally just does text replacement. When it sees that hashtag include, it takes that standard IO header file and literally just pastes it into your code. You can actually see the output of this by adding a TAC-E flag when you compile your program. The preprocessor has a couple of other commands, like define, which is useful for constants. Again, the preprocessor just takes this and replaces the word pi with 3.14159. I'll also point out that this 2 times 3.14159 will get simplified by the compiler, the next step of the build process. So your code is basically equivalent to this. You can also do functions with define. Here, it'll replace square of radius with radius times radius. But you've got to be super careful with this. See, you might think that square of 3 plus 3 would be 36, but in fact it's 15. Why? Remember, the preprocessor literally just does text replacement. Besides hash include and hash define, there are also other preprocessor commands that we'll need to know. One is undef, which undefines a previously defined macro. We can also do conditionals to check whether or not something is defined. Here, we're checking whether the macro pi is defined. If it is, the declaration of y is given to the compiler. Otherwise, that line gets completely ignored. Now, coming back to the desired interface for our package, we need to keep arrays of the different arguments. The question is, if the preprocessor only does literal text replacement, how the heck are we supposed to do arrays with the preprocessor? After doing some digging, I found this thing called the X macro pattern, which I, at least, had never heard of. Let's walk through how it works. Here, we're defining a macro called list, and we're using the backslash to create a new line that is still part of the macro. Notice that the macro element is not yet defined, so we can change the definition of it throughout our code and then place list wherever needed. Look at what happens when we build this code. The preprocessor replaces the text list with our list, and of course each element of X just becomes the corresponding print statement. We can do pretty much anything with these, but you do have to get pretty crafty. For example, how do you think you would calculate the length of your array? I'll give you a second to pause and think about it. We can assign each element to be +1. Then, list becomes a sequence of +1s equal to the length of our list. And again, the compiler has a very easy time optimizing this, so it ends up being equivalent to just setting the length equal to 3 after compiling. Now that you've got the idea for how the X macro pattern works, let's get back to writing our argument parser. We'll need the developer, the user of our library, to specify a list of their required optional and Boolean arguments. We now know that this will need to be an X macro list. Note that each element is an arg, and the lists themselves are called args with an S. We'll talk about what exactly will go between those brackets shortly. In our code, we'll redefine what each element corresponds to in order to accomplish different tasks. For example, let's look at making our args t-struct. To do this, we need a type and a name for each of our arguments. And of course, we have to make sure to undefine each of these right afterwards. We can define each of these arguments to be equal to type name semicolon, and then just put each list in our struct. Before this code is passed to the compiler, the preprocessor will turn this into a regular old struct definition. We now have a way for our args struct type to be automatically generated. We can then go through a similar process for all the rest of our functions, albeit with their own little tricks. And I'm also going to specify some helper functions for common types of required and optional arguments, just to improve the developer experience slightly. And now we're just about done. Let's see what it looks like in action. We start by specifying the arguments, including their names, labels, and a short description of the help string. We also need to specify the default values for optional arguments. Note that the type is chosen in the name of our macro, using those helper macros I created earlier. Then, if we include our library, we can keep our main function as is. All the other implementation details are handled by our header file. As far as I've seen, this is the easiest way to get argument parsing working, in terms of both having no boilerplate and having straightforward maintainability. The code is all on GitHub if you want to check it out. Thanks for watching.